Good morning. Today we'll be starting with chapter 10, which is straight lines. As you all are already aware, through a given point we can draw infinitely many straight lines. Now, to be able to uniquely identify a particular line, say L, we either need one more point lying on that line along with the initial point, or we know the direction of that line. Okay, so now we are going to, in this class, we are going to introduce the concept of slope of a line. Though all the questions can be done with a variety of concepts, but in this year you will be expected to use the concept of slope to be able to solve the questions. Okay, now again you all are aware of inclination of a line. So I'll just do a quick recap. Given any straight line, now first of all, as a reference point we take the x-axis always, and that too the positive x-axis. Now given any straight line, it will always make two angles with the x-axis. Okay, one will be in general an acute angle and the other one would be an obtuse angle, unless and until the line L is perpendicular to the x-axis or along the x-axis or parallel to the x-axis. So anyways, it will always make two angles with the x-axis. Okay, let's take the angle is theta. Now the angle which the straight line makes with the positive x-axis measured in the anti-clockwise direction is called as the inclination of the line. Okay, so I'll just quickly repeat. Given any straight line, it always makes two angles with the x-axis. Now that angle which is made with the positive x direction measured in the anti-clockwise direction is called as the inclination of the line. So very clearly the angle theta will lie between 0 and 180 degrees. Okay, so again I repeat, as in trigonometry we have already seen this, that we always take the inclination of the line to be positive when measured in the anti-clockwise direction. Okay, so now this is the inclination. Now we come to the slope of the line L. So slope of L. Given any line, let it make an angle theta with the positive x direction measured in the anti-clockwise direction. So we call this theta as the inclination of the line L. Now, so slope of the line is taken to be tangent of this inclination. That is, how we define slope is, given a line L having inclination theta with the positive x-axis, then slope of L is defined to be tan theta. So we take the tangent of this angle, and tan of theta is called as the slope. It is denoted by small m. So slope of line L equal to tan theta and is denoted by small n. Now clearly any line which is parallel to the x-axis will have the angle of inclination 0 degree. So a line parallel to x axis has angle of inclination as 0 degree. Therefore, slope of line parallel to x axis is always 0. Similarly, a line parallel to y axis has angle of inclination as 90 degrees, because angle of inclination is always measured from the positive x-axis, and y-axis or any line parallel to the y-axis always makes an angle 90 degree with the positive direction of x-axis, and so the angle of inclination would be 90 degree. And since tan of 90 is not defined, therefore, but tan 90 is not defined, therefore slope of a line parallel to y axis is not defined. So this is the concept of slope of a line. Now we come to various forms of finding the slope of the line. Now suppose instead of being given the angle of inclination, suppose we are given 2 points lying on a line, then also the line can be uniquely identified, as we have already discussed that a line can be identified uniquely if either we have 2 points lying on that line or we know 1 point and the direction of the line. So just now we have seen that how to find the slope of the line when the direction or the inclination of the line is given to us. Now so what we have to do now is slope of a line if 2 points lying on the line are given to us. Now for this, what we do is, now let us consider a straight line inclined at an angle theta with the positive x-axis. Now this is the y-axis, this is the origin. Okay, let the line L be given to us. Now consider 2 points lying on this line. One is the point P, which is x1, y1, and the other is the point Q, which has coordinates x2, y2. Now we have to find the slope of this line. So what we do is, first of all, we will draw a line parallel to the x-axis through the point P, and through the point Q draw a line parallel to the y-axis, so that this makes a right angle triangle, and let's call it R, and let's call this point as S. So this becomes a right angle triangle, and clearly the line PR would be parallel to the x-axis, and by the concept of corresponding angles we have the angle QPR is equal to theta. Now we know that slope, by definition, slope of L is equal to M is equal to tan theta. Now we also know that tan theta is equal to opposite side upon the base, and so from the triangle QPR we have it is equal to tan theta would be equal to QR upon PR. Okay, so we get the slope of L equal to M is equal. Now what is QR? Now we can clearly see that the coordinates of the point R would be, it will have the same y coordinate, and the x coordinate will same y coordinate as the point P, and it will have the same x coordinate as the point Q. So the coordinates of the point R would be x2, y1. Now the length QR would be actually the distance between the two, or the difference between the two y coordinates. So it is equal to y2 minus y1 upon the length of this PR would be the difference of the x coordinates of the 2 points. So it will be x2 minus x1, and hence we get another formula for the slope of the line as slope of the line L is equal to small m will be equal to the difference of the two y coordinates upon the difference of the two x coordinates. Now what happens if instead of making an acute angle with the x-axis, suppose the line makes an obtuse angle? Then let's see what difference it makes in the formula for the slope of the line. So let's take another case that we have. Let the slope the line be something like this, and let's call this L. Now this is the angle which it makes with the positive x direction. So let this be theta, and this is equal to the y axis, and this is the origin. Now so the points, let's consider the 2 points as P and Q. P is x1 y1 and Q is x2 y2. Just like before, we will be dropping perpendiculars from the point Q to the x-axis, and we'll draw a line parallel to the x-axis through P. Same way here also we do the same thing. We drop a perpendicular from Q onto the x-axis, or you can say that we are drawing a line parallel to the y-axis through Q and parallel to the x-axis through P. So we arrive at a point R here, and let this be S. This becomes a right angled triangle. Now let's see the coordinates of the point R. It will have the same x coordinate as Q, which is x2, and the same y coordinate as P, which is y1. And so the coordinates of R would be x2, y1. Now, so going by the corresponding angles, this angle is theta, and so the angle which the point P makes, or the acute angle here, or the angle P in the triangle QPR would be 180 minus theta. Okay, so what we have done, exactly on the same lines, we have taken a line which makes an obtuse angle with the positive x-axis. Same way we have taken 2 points P and Q lying on that line. Through P and Q we have drawn lines parallel to the x-axis and the y-axis respectively, which meet at the point R, making a right angle triangle QPR. Now going by the corresponding angles, since the line PR is parallel to the x-axis, going by the corresponding angles, this angle is angle theta, and so the angle QPR becomes 180 minus theta. Now, so tan 180 minus theta. So let's find the value of this one. Now, what we get is the slope would be, now slope of the line, by definition, slope of L is equal to M, which is equal to tan of theta. Okay, now this is tan of theta is the required slope. Okay, now from this triangle, again let's find, now in this triangle, in triangle QPR, we have tan of 180 minus theta is equal to tan of 180 minus theta is equal to QR over RP, or QR over RP. Okay, now what is QR over here? QR is since the x coordinates are the same, QR is nothing but the difference of the two y coordinates, which is y2 minus y1, whereas RP is nothing but the difference between the two x coordinates, which is x1 minus x2. So we have it as y2 minus y1 upon x1 minus x2. Now let's call this equation, slope of L is m, which is tan theta, we call it 1. Now let's find the value of tan theta from this triangle, and let's see. Tan 180 minus theta is QR over RP, which is y2 minus y1 over x1 minus x2, which can be written as y2 minus y1 upon minus of x2 minus x1. Now, but by the identity, we have tan of 180 minus theta is minus 1 tan of theta, and here we have minus y2 minus y1 over x2 minus x1. This negative sign gets cancelled with this one, and we get tan of theta equal to y2 minus y1 upon x2 minus x1. Let's call it equation number 2. Now from 1 and 2 we get slope of L is equal to m is equal to tan theta is equal to y2 minus y1 over x2 minus x1, which we observe is the same as what we observed when the angle was acute. So we conclude that no matter whether the angle is acute or obtuse, the slope of line on which we are given two different points will always be equal to, slope of L will always be equal to the difference between the y coordinates of the two points upon the difference between the corresponding, now this point is very important, corresponding x coordinates of the two points. So basically, no matter which points we take, which point we take as the first point and which point we take as the second point, it's only the difference of the y coordinates upon the difference of the corresponding x coordinates. So we have to be only careful that whichever y coordinate we take first, like as y2, the corresponding x coordinate only has to be taken as x2. Like, let's take an example. Now for example, now if we have to find the slope of the lines passing through the points 3, minus 2 and minus 1, 4 to find the slope. So slope will be equal to, slope is equal to m is equal to y2 minus y1 upon x2 minus x1. So here let x1 y1 equal to 3 minus 2 and x2 y2 equal to minus 1, 4. We could have taken the other way also. Okay, so now let's first take with this way. Now y2 minus y1, y2 is 4 minus y1 is minus 2 upon x2 is minus 1 minus x1 is 3. So it gives us 4 plus 2, which is 6 upon minus 4, which is minus 3 by 2. Now suppose we had taken x1 y1 as minus 1, 4 and x2 y2 as 3 comma minus 2. Then slope is equal to m equal to y2 minus y1 upon x2 minus x1, which comes out to be, now y2 is minus 2 minus y1 is 4 upon x2 is 3 minus x1 is minus 1, which comes out to be minus 6 upon 4, which comes out to be minus 3 by 2. As you can clearly see, both the results is exactly the same. So we conclude that irrespective of which point we take first, the slope will always be defined as the difference of the y coordinates of the 2 points upon the difference between the corresponding x coordinates. Okay, so with this, given any, whether you are given the inclination of the line or you are given any 2 points given on the line, you can easily find the slope. If it is given, if the inclination is given, you can find the slope as m equal to tan theta, whereas if the 2 points lying on the line are given to us, then the slope can be found out as m equal to y2 minus y1 upon x2 minus x1. Thank you.